thank you. We were actually faster, so I just start off a little QA session here, the last minute. So my first question, so I open it up to the public as well. I should step into the light.
I will run around with microphone.
So we will run here and we will call upon not only you, but on everyone on these pitches. So my first question is, so you say you're a researcher at RISE, so have you applied this on any industry software?
Actually, we are planning to apply on the industrial cases, but actually we did our evaluation based on some well-known benchmarks.
Okay, so if Ericsson really says, come on here, we have some complex performance testing, you would take on that challenge, right?
Yeah, sure.
Sure, yeah, that was my first. Okay. So you say it's only for mathematical properties, but isn't it so that you can use that if you have other types of relations? Because I think my super test case isn't that when you have, for instance, permutation of input, right? Even if you have the input in different order, you still want the same output, right?
Yes. Yeah.
So isn't that also, that's not really mathematical in that sense? Can't you extend it to more than sinus functions?
Basically, what it requires is some mathematical properties. It need not be full 100% mathematical operations. Like for example, if you take any radio software or embedded systems, it will have one or the other mathematical property in any of the code piece or any function. So what it tries to harness is the mathematical properties present in code, and the more the mathematical properties, the more accurate it can be.
So can't you expand it to saying there are some physical relations? Like, I don't know what we say, above water is always certain and underwater is another. So there you can transform testing problems very easily into mathematical problems as well.
Exactly.
Okay.
And this can be also done in case of test requirements as well. Rather than test cases, like how based on some requirements you can even transform the requirements as well. Just apart from the test case.
But it's a very, very novel technique, not at all as mature as as mutation testing, but very exciting nevertheless. And I think, especially at Ericsson, the radio has a lot of algorithm in it with mathematical properties that this could generate thousands of new test cases, right? And find bugs, of course. Thank you, Arvind.
Adam, I would like to ask you, what would be your dream repository to analyze with your tool, and why?
So my dream repository, I'm pretty sure it has to be Windows Vista, which I have a fairly good idea what it will look like. I've never seen the source code, but I have the unfortunate experience of using it. And it's claimed to be one of the biggest commercial code bases ever written, with close to 50 million lines of code. So that would be fun.
Okay, considering the flaky test, I wanted to know whether you have data on the causes of flaky tests. So for example, something that is quite interesting for me was the categories that you showed, that these are the causes of the normal flaky test. But do you have like a database that says 10% this?
Usually most... Hello, So you can find this on the literature, that most of the research has been done over open source software, where they go for a commits that says flaky, and they dig deep and they find out the causes. So there are, and one multi-vocal review where a person has gone through blogs, not only academic papers, and he find out 200 causes, and then they categorize it on that. But what we also done, that we haven't gone only through the open source software, but we have also got the data from industry. And one of the funny cases I would like to share here, that with one company, and they spent 3 days to find out why test case is flaky, is because of time-saving day. So their test case failed, and it was a daylight saving time on 29th October, and they spent whole day on it because their test case was taking a time increased by 1 hour and then testing it. But actually the device has already been updated. So they spend 1 hour on it. So we have the data as a software center company from the companies. But if you want to study, there is a literature that tells about these 200 cases about thread.sleep and resource optimization, if that's the question.
Well, for me, it's like it's basically personal grievance, because I had the trouble of going through a lot of flaky tests recently to find out the problem. As you know, mutation testing goes over a test suite multiple times. Let's talk in order of 10,000, 20,000 sometimes. And if a test is flaky 1 in 1,000, it will mean that 20 times you get mutants that are killed for absolutely no reason. And it's completely irrelevant to the mutant itself. It's a test that is just failing randomly. And in this case, I saw a lot of tests that even the developer says this test fails 1 in 1,000. And yeah, that was kind of surprising for me. So I thought maybe you have some data on it.
Yes.
Thanks.
But that data is only available on the code level. That don't write this code, but nothing else. So yes, that data is available online in the paper. You can search it on IEEE.
Thank you very much.
Thank you.
So we talked a lot about mutation testing and a lot of issues that we're going to suffer then, from what I can see, is the oracles behind them. Because if you're going to have these thousands and thousands of test cases, you have to review all of them. So we've already established through other discussions that oracles are very time consuming. So is there a way of not creating an oracle but still getting the benefits of mutation testing?
Well, you still have to determine what's correct, but I think autonomous test, right? I don't know if I'm the right person to answer this, but that's the whole point of autonomous tests. Really do the automation all the way, so you don't have to be the oracle. You have automated the oracle, right? And this is what I think you're struggling with a little, not only to speed it up, but at some point you have to say what's correct. Whatever technology you do, what is correct? And if you haven't specified that from the beginning, which is often the case, someone human still has to go in and look at that. And I don't think currently there is the magic to do that. But the better we specify and do our requirements, I think the better we can solve oracles, right?
Well,
Do you agree on that?
Yes, but I've noticed that we are basing mutations based off current test cases we've created. So people have manually gone in, created an original test case and manually reviewed it and said it's okay. And then you come along and then do all the mutation testing later.
Yeah.
So is there a way of using these original test cases, original results, original review, and feeding that back into the mutation? Instead of doing an oracle, someone's just done a manual review saying this looks about right, these graph outputs look about right. Therefore, there's a way of then using that information inside to create a virtual oracle that mutation testing can use.
So, Serge, are you up for the answer?
It's intriguing what you mentioned, because the whole thing about mutation testing, it's actually a test of your tests. And so it starts from the basic assumption that you already have good tests, that they pass, they are green, and they want to see that they pass when they should pass and that they fail when they should fail. What you're actually suggesting is that you have some kind of smarter ways of doing testing, where you have you write a few simple unit tests and then use mutation tests to actually improve your tests. That's what you're suggesting.
Well, they're going to the robustness testing side of things, yes. But you can use the approach that you've already know the inputs, you already know the outputs, and then you can use some sort of smarts to know that these original test cases, the mutations should look similar to those results as previous test cases. Otherwise, we're going to spend a huge amount of time doing oracles.
Yeah, so I think it's an interesting suggestion, but for the moment, the state of the art in mutation testing is not yet there.
So we still need oracles.
Yeah.
Okay.
But actually what you're talking about, Aravind, this is very close, I would say, to metamorphosis test. So maybe we didn't explain that well enough. But that's really the whole thing. It assumes you have a good test suite, you have the good tests and the result, right? And then you're trying to manipulate, and one way you manipulate is machine learning, mutations, whatever, and the result should remain still valid, right? And if something goes wrong, now you find a new path in your code, or you address the combination that no one have thought about. So I think this is exactly what the metamorphosis testing is sort of after. But again, it has a lot of application. It's still new. People are sort of testing the waters there. But I'm glad you're on it, because maybe you have some new ideas here.
It sounds really good, and you're exactly right. And I thought if the combination of both techniques were thought about being used, because I can see a huge benefit.
And I think this is the future. It's not one unique technique that solves everything. It's like you do model-based test generation, you do mutation testing, you do machine learning, you do metamorphosis testing, and on that you have optimization techniques, etc., etc. And here you go. Static analysis absolutely combined. So even if we think, oh, that's on code level, static analysis, we don't need that. And then you also need the dynamic analysis, and I think it's really good codes in here, behavior analysis, how you reason about things. There is a lot of sort of levels of knowledge we can combine to bring new ways of doing this. But I think I see the whole quest, and I see this whole seminar is about really thinking, how can we automate better away problems we have, and what can we build into the computers.